Welcome to the Groove Guide Podcast. I'm Earl, your host, and here with me is Miriam, our amazing guest.
It is fantastic to be here. I have been looking forward to this one because the research stack we're covering today is, honestly, it's one of the most compelling I've seen in a long time.
I feel the same way. We usually talk about maintenance on this show.
Right.
You know, how to keep the machine running, how to stop things from breaking down.
Right.
But today, we are flipping the script. We are looking at a source material stack focused on Hericium erinaceus, better known as lion's mane mushroom.
Mm-hmm.
And the bold question I want to pose to you and to everyone listening right now is this. What if there was a natural ingredient that didn't just protect your brain from aging, but actually helped it repair itself?
It's a massive concept.
It is. We are talking about literally regrowing the physical connections in your head. It sounds like sci-fi or maybe something you'd read in a comic book, but the science we have in front of us is pointing right at it.
It really is. And what's fascinating here is that while this mushroom is often labeled a nootropic or a smart drug, those terms almost sell it short.
How so?
It's doing something much more fundamental to our biology than just giving you, like, a caffeine buzz.
Before we get into the mechanics, because I know we have some heavy chemistry to unpack, we have to set the scene visually.
Yes.
I was looking at the photos in our research notes, and if I saw this thing in the woods, I would not think mushroom.
Not at all. Not even close.
It doesn't have a cap. It doesn't have a stem. It doesn't look like a pizza topping.
It definitely does not.
Right.
It grows exclusively on heartwood trees, usually dead or dying ones, like oak or beech. And instead of that umbrella shape, it looks like a cascading waterfall of white icicles.
A waterfall of icicles is a great description. To me, it looked like a shaggy white pom-pom.
Yeah.
Or maybe a cheerleader's pom-pom that got left out in the rain.
That's a very common comparison. Or a bearded tooth. In fact, the Latin name Hericium actually relates to a hedgehog.
A hedgehog, okay.
Yeah, it's this white globe-shaped mass covered in these soft dangling spines. It is incredibly distinctive.
So we have this shaggy hedgehog-looking fungus growing on a dying oak tree. Let's get into the why. Why are we talking about this in the context of brain health?
Right.
What is actually happening inside our heads when we introduce this organism to our system? And I want you to break this down for us, but let's keep the biology textbook closed for a second. Explain it like I'm 5.
Okay. I love the explain it like I'm 5 challenge. Let's use an analogy. Imagine your brain is a garden, a really lush, complex garden.
I'm picturing it. Hopefully there are no weeds.
We'll get to the weeds later. But in this garden, your neurons, the brain cells that hold your memories and skills, they're the plants.
Yep.
Now, for any garden to thrive, the plants need good soil, water, and crucially, they need fertilizer.
Right.
In the human brain, that fertilizer is a specific protein called nerve growth factor, or NGF.
Okay,
NGF is the hero of the story. It helps your neurons survive, it keeps them healthy, and most importantly, it stimulates them to grow new branches. We call them neurites, so they can connect to other plants in the garden.
So it's building the network.
It's what keeps the network dense and alive.
So NGF is the miracle growth.
Exactly. But here is the problem. As we age, or if we are under chronic stress, our brain's production of this fertilizer slows down. It's like a drought sets in. The soil gets dry, the plants start to wither, the connections break.
And that's where we see the senior moments, the brain fog, the forgetfulness.
Precisely. That is cognitive decline. Now, the logical solution would be, okay, let's just make a pill out of NGF and swallow it.
Replace the fertilizer.
Right. But we can't. The brain has a very strict security guard called the blood-brain barrier.
Right.
Its job is to keep toxins out, but it's so strict that it also keeps large beneficial molecules out. The NGF protein is simply too big. It's like trying to shove a grand piano through a cat flap. It just won't fit.
So you can eat all the NGF you want, but it's never getting into the garden.
Exactly. It bounces right off the gate, and this is where lion's mane becomes the star. This mushroom doesn't contain NGF. Instead, it contains these very small, specialized compounds, low molecular weight compounds that are essentially VIP guests.
They fit through the cat flap.
They slide right through, they cross the blood-brain barrier, enter the brain, and once they're inside, they stimulate the brain to manufacture its own fertilizer.
That is a massive distinction. So it's not adding the fuel, it's fixing the pump.
That is the perfect way to put it. It stimulates the synthesis of nerve growth factor from within. It wakes up the garden's own irrigation system.
So we have a mechanism that makes sense. But mechanisms are one thing, actual results in actual people are another. I know we have a stack of animal studies here involving mice, but I want to look at the human data. There was one study in our notes from 2009, Mori and colleagues, that seems to be the one everyone points to.
Mm-hmm.
Let's unpack that.
This is a pivotal study. It's really the gold standard because it was a double-blind, placebo-controlled clinical trial. They took 30 Japanese men and women aged 50 to 80.
And these weren't healthy college kids, right?
No, and that's a key point.
Mm-hmm.
These participants had all been diagnosed with mild cognitive impairment. They were already showing the signs of the garden drying up, so to speak.
Okay. What did they do?
For 16 weeks, half the group took tablets containing dry lion's mane powder, about 3 grams a day, and the other half took a placebo.
And the results?
The results were stark. They tested them at 8 weeks, 12 weeks, and 16 weeks using a standard dementia scale. And the group taking the mushroom showed significantly increased scores compared to the placebo group.
So not just a little bit.
No, we aren't talking about a tiny margin of error here. They were performing better on memory and general cognitive tasks.
That sounds like a slam dunk. The stuff works.
It is impressive, but there is a twist in this study. And honestly, I think this twist is the most important takeaway for anyone listening who is thinking about trying this.
Here's where it gets really interesting. What was the twist?
After the 16 weeks were up, the researchers told the participants to stop taking the mushroom.
Just stopped it cold.
They stopped the supplementation entirely. Then the researchers came back and tested them 4 weeks later.
Let me guess. The scores dropped.
The scores dropped significantly. They went almost back down to where they started.
Wow. So what does this all mean? Does that mean it didn't actually fix anything?
It's a great question. It suggests that lion's mane acts functionally. Think of it like diet or exercise. If you go to the gym for 4 months, you get strong. If you stop going for a month,
You start to lose it. The muscles atrophy.
exactly. The study indicates that for neuroprotection, the mechanism requires constant stimulation. As long as those VIP compounds are entering the brain, the NGF production is elevated. When you stop, the production slows down again.
So it's not a one-time cure. It's a maintenance protocol.
It is absolutely a maintenance tool. You have to keep watering the garden if you want it to stay green.
That is such a crucial insight. I feel like a lot of people try supplements for a month, feel a difference, stop, and then wonder why the fog comes back.
Right.
This explains exactly why.
It does. Consistency is the variable that matters most here.
Now, speaking of variables, I want to pivot to something that I see argued about constantly online. If you go online right now or walk into a health food store to buy lion's mane, you are going to get hit with this confusing debate. Fruiting body versus mycelium.
Oh, this is the great debate of the mushroom world. Yes.
It gets heated. I've read forums where people say you should only buy the fruiting body, the actual mushroom part. The mycelium is just the roots, it's cheap filler, it's garbage.
It is a very persuasive narrative, and it's very common in marketing. But if we look at the biochemistry, that narrative is actually backwards.
Okay, let's bust this myth. Why is the mycelium is trash idea wrong?
To understand this, we have to go back to those VIP compounds we talked about, the ones that cross the blood-brain barrier.
Okay,
It turns out there are 2 main families of these compounds in lion's mane.
2 families.
Okay. Family number 1 is called hericinones. These are found primarily in the fruiting body, the white pom-pom part that you can see.
The part you would chop up and put in the stir fry.
Exactly. And hericinones are great. They have immune benefits. They are healthy. But, and this is a big but, the research suggests they might struggle to cross the blood-brain barrier effectively. They aren't the most efficient messengers for that specific job.
So the mushroom part that everyone insists on might actually be the weaker part when it comes to brain repair.
For NGF specifically, yes. The heavy lifting is done by the second family of compounds, erinacines.
Erinacines.
Specifically erinacine A and erinacine S. These are the most potent stimulators of nerve growth factor, and they are the ones confirmed to cross the blood-brain barrier easily.
And let me guess, where do we find these erinacines?
They are found almost exclusively in the mycelium, the root system.
That is wild. So if you listen to the internet marketers and buy a 100% fruiting body extract, you're actively filtering out the most potent brain compound.
You are missing the erinacines. You are missing the very mechanism that drives the deep neuro repair we are so excited about.
So why does the myth exist? Is it just ignorance? Or is there a reason people hate on the mycelium?
There is a valid reason for the skepticism, even if the conclusion is wrong. It comes down to how it's grown. In commercial production, you don't dig mycelium out of the dirt in the forest. You grow it in a lab on a substrate, usually a grain like brown rice or oats.
Okay, so the roots grow into the rice.
Exactly. The mycelium eats the rice, it colonizes it, But if a manufacturer is lazy or trying to cut costs, they might harvest it too early.
Before it's done eating.
Before the mycelium has fully consumed the grain, then they grind it all up.
And you end up with a capsule that is mostly expensive rice flour with a sprinkling of fungus.
That is grain filler, and that is what people are rightfully angry about. You don't want to pay $50 for ground up rice.
So the critics are right about the risk of bad manufacturing, but they are wrong about the biology of the mushroom itself.
Precisely. You want the mycelium, but you want it from a high-quality source where the mycelium is fermented properly and the grain is fully consumed. In fact, many of the advanced neurostudies specifically use mycelium-enriched extracts because they need those erinaceins to get the results.
That is a massive aha moment for me. You need the roots. The roots are where the magic is.
The roots are essential.
Okay, moving beyond the wiring and the chemistry. We talked about the brain as a computer or a garden memory, cognition, but we are also emotional creatures. And one of the sources in our stack mentioned a study involving cookies.
Yes, the Nagano study from 2010. I love this study because it's just so relatable.
I would definitely sign up for a clinical trial that involved eating cookies every day.
I think we all would. They took a group of women and gave them cookies containing lion's mane, about 2 grams a day, or placebo cookies. They did this for 4 weeks.
And what did they find?
The results were fascinating. The women eating the lion's mane cookies reported significantly lower levels of anxiety and irritation compared to the placebo group.
So it wasn't just memory, it was mood.
It was mood regulation, and physically they reported fewer complaints of palpitations, so their physiological stress response was actually dialed down.
Is that the NGF again? Or is there something else happening here?
It's likely a combination, but this links us to another huge topic, the gut-brain axis.
Right.
We know now that the gut and the brain are constantly texting each other via the vagus nerve. If your gut is inflamed or unhappy, your brain feels anxious.
And lion's mane works on the gut.
Historically, before we knew anything about neurons, that was its main use. Traditional Chinese medicine used lion's mane for digestion, gastric ulcers, and general gut weakness.
I had no idea.
And modern science backs this up. It has been shown to fight Helicobacter pylori, the bacteria that causes ulcers, and it helps regenerate the stomach lining.
So by healing the gut and calming that inflammation, you are lowering the noise signal going to the brain.
Exactly. A calmer gut often leads to a clearer, less anxious mind. It's a full system approach. It's treating the hardware and the software at the same time.
It really is incredible how interconnected it all is. But look, we have to be responsible guides here. We've hyped the benefits, brain repair, memory, mood, gut health. But is this safe for everyone? Or are there people listening who need to hit the pause button?
That is a very important question. Generally speaking, lion's mane is very safe. It is a culinary mushroom. People buy it at farmers markets and eat it like a steak. It has GAS status, generally recognized as safe.
Okay.
However, because it is bioactive, it does interact with certain conditions.
Let's run through the red flags.
First up is diabetes. Lion's mane has been shown to lower blood sugar levels.
Which sounds like a good thing for most people.
It is a good thing unless you are already taking strong medication to lower your blood sugar. If you combine the mushroom with insulin or something like metformin, your blood sugar could drop to low hypoglycemia.
That's dangerous.
So if you are diabetic, you need to monitor that closely and talk to your doctor.
All right, that's number one. What's number two?
Blood clotting. Lion's mane has a mild anti-clotting effect. It slows down platelet aggregation.
So if you cut yourself, you might bleed a little longer.
A little bit. For most people, this isn't an issue. But if you are on blood thinners like warfarin, or if you have a bleeding disorder, you need to be very careful. The combination could increase the risk of bruising or bleeding.
And I assume if you have surgery coming up,
Standard advice applies. Stop taking it 2 weeks beforehand. You don't want to complicate the healing process.
and allergies, I mean, it's obvious, but
Obviously, if you are allergic to mushrooms, do not eat this. It's rare, but some people can have skin rashes or breathing issues if they are sensitive to fungi.
good to know. It's always smart to check the fine print. So we've covered the garden analogy, the twist in the Mori study, the myth of the mycelium, and the gut-brain connection.
We have covered a lot of ground today.
I want to leave our listener with something concrete. If someone is listening to this and thinking, okay, I'm sold, I want to water the garden, I want to try this, what is the one actionable tip you would give them for shopping? Because the supplement aisle is a confusing place.
My biggest tip is this. Look for the words full spectrum.
Full spectrum.
Don't get caught up in the fruiting body only marketing hype. As we discussed, if you do that, you are missing the erinaceus. Look for a product that explicitly includes both the fruiting body and the mycelium.
Okay.
Or look for a label that specifies it contains both heracinos and erinaceus.
You want the whole package because the different parts do different jobs.
Exactly. You want the whole organism working for you. And the second part of that tip is commit to consistency.
Right, because of the drop-off we saw in the study.
Exactly. This isn't a take it when I have a test tomorrow kind of pill. It doesn't work like caffeine. It's a take it every morning with my coffee lifestyle. The biological mechanism relies on that constant signal to the brain to keep producing NGF.
You have to keep watering the garden. It's a commitment, not a hack.
That's the perfect way to frame it.
You know, what strikes me about this whole deep dive is how we are essentially rediscovering something ancient. We are using high-tech liquid chromatography and double-blind studies to validate what people have known intuitively for centuries. It's like the fungus figured out how to hack our nervous system millions of years ago, and we're just now reading the code.
It really highlights how connected we are to these organisms. We aren't separate from nature. The fact that a compound in a mushroom growing on a dead tree fits the lock in our human blood-brain barrier so perfectly, it's profound.
It really is. It's a reminder that sometimes the best technology isn't silicon, it's biology.
I couldn't agree more.
A profound thought to end on. Before we go, I have to say the mandatory bit. This podcast is for educational purposes. If you're pregnant or thinking about trying something new, always consult with your doctor first.
Always good advice.
If you want to dig deeper into the studies we mentioned today, or maybe find links to some of those full-spectrum products we talked about, head over to grooveguide.io. And for more visual content, maybe to see what that weird bearded tooth mushroom actually looks like in the wild, check out Groove Guide TV.
It's worth a look. It is a beautiful organism.
Thank you so much for breaking this down for us.
My pleasure.
And to our listeners.
Stay curious.
Keep growing.